Hey there, pre-calc friends. Today we're going to talk about section 4.5, which is called the Law of Cosines. It makes sense that we had a law of sines, so we also have a law of cosines. We actually, believe it or not, have a law of tangents, but we don't learn that in pre-calculus, so you don't have to worry about it. But the law of cosines overall is actually really cool, because we just came from the crazy law of sines, which had that really tricky SSA case, right? The ambiguous case. And that was really tricky to play with. But just knowing law of cosines, we don't ever have to worry about it. So we'll see that law of cosines is really easy to use, a little bit more algebraic, but just awesome that we don't have to worry about that crazy ambiguous case from the law of sines. Alright, so here's how it's going to work. I'm going to throw a triangle at you, and he's not a right triangle, so we need to find more ways to solve for his sides and angles. What if I give you a triangle like this, ABC, and I give you this side, and I give you this side, and I give you this side? What case is that? Do you see that as we walk around? That is SSS, right? If you ever have an SSS triangle, you will always use the law of cosines. How about this one over here? What if I give you, how about this side and this side, but I'll give you this angle that's right in between the two sides? What case is that? It is SAS, right? And notice that is very different than this over here. Right? I am giving you two sides of an angle, but this angle is in between. So important, this is in between, so this is SAS and not the SSA evil case. Okay, if you see SAS, you are using law of cosines. So it's really good. Why don't we just take a second and just review really quick which cases are law of sines and which cases are law of cosines. So now we know that law of cosines is SSS and SAS. What were the ones for law of sines? Do we remember? We know, of course, the evil one, the SSA. But do you remember? How about angle, side angle? And angle, angle, side. Okay, so those are the cases for law of sines. And if you don't have those, if you have these two over here, then you're going to be using the new law of cosines. All right, here's what it looks like. It's going to look kind of familiar at first, actually. Ready? This is the law of cosines. And it's going to start familiar. Ready? Side C squared equals side A squared plus side B squared. Okay, stop. Doesn't that look familiar? Haven't we seen that before? Yeah, it's Pythagorean, right? But remember, Pythagorean is only for right triangles. And because these are not necessarily right triangles, we're going to adjust it. So we're going to do A squared plus B squared, and we're going to take away two of those same letters. We have A's and B's, so we're going to take away two A's and B's. Multiply by, this is the law of cosines, right? Multiply by the cosine of the angle opposite the side you started with. We started with C squared, so we're going to take the cosine of angle C. That's called the law of cosines. C squared equals A squared plus B squared minus the same ABs that we had here, minus 2ABs, cosine of the angle opposite of the starting side. Okay? Now, if you wanted to, you can start really with any of the three letters. For example, what if I started with B squared equals, well, see, what would be the rest? It'd be the other two sides squared, A squared plus C squared. I'm going to take away two of the same sides that were on that right side, right? Now it's A's and C's, so minus 2AC times the cosine of, which angle do you think? Which one did we start with? Which side? B, right? So times the cosine of angle B. Now, can you figure out which one we haven't used yet? We started with C squared, with B squared. How about A squared? Ready? See if you can do it with me. A squared equals B squared plus C squared minus 2 times BC times the cosine of angle A. Now, do you have to memorize all three of these? No, not at all. You just memorize one, and you can adjust the letters based on what you're given and what you need. So I tend just to memorize this top one here because it looks a little bit like Pythagorean, and then I can memorize the other ones based on that. If you want to know what it is, really was the law of cosines just in terms of plain English, you don't have to write this down, but just know it is one side squared is the other two sides squared and added minus 2 times those same sides times the cosine of the angle that you started with. The angle opposite of the side you started with. All right, now, do you have to know that in English? No, not really, but in case you like that, it's there. Great news, though. Like we said before, there's nothing ambiguous here. Nothing. No way. Everything is one triangle and one triangle only. Okay, so we don't have to worry about searching that. It's only law of sines and only SSA. Let's play. All right. So same steps as always, folks. Figure out what you're given. Draw a triangle so you know what case you're given, so you know which law to use, and then start making your answer box. All right, here, number 1, folks, I'm given side A is 3, so I'll put that in. Side B is 7, and angle C is 130 degrees. All right, why don't we draw a triangle? Sounds good. So now I'm given side A over here, I'm given side B over here, and I'm given angle C right here. Okay, if you can see, this is SAS, which is definitely law of cosines, and only one triangle. Okay, awesome, let's do it. Now, when we set up and use the law of cosines formulas that we have here, depending on what you're given, if you're given an angle, it's probably helpful to start with the side that's opposite of that angle. So for example, on this one, we have angle C. So it's probably good to use the equation that starts with C. This one here. Minus, take away 2 of the AB's times the cosine of angle C. So I would use that one because we're given angle C, we should start with side C. And before we plug anything in, just take a look. We don't have side C, but we have side A, we have side B, and we have A and we have B, and we do have angle C. So we can actually, once we plug this in, put the whole thing straight into the calculator and we'll be home free. All right, let's do it. C squared equals A squared plus B squared minus 2 times AB times the cosine of 130 degrees. There we go. And we can just go, like I said, straight across, put it right into your calculator, and good to go. But just remember that this is C squared, so your last step would be to square root. So you can put all these things together. I'm just going to do it by hand so you can see it. I'm actually going to make a really big mistake in a second. I wonder if you can figure out what my mistake is. And calculator and go. But I made a mistake. Can you figure out what my mistake is? What did I do wrong here? It's right here. Do you see how I got that? I saw these two numbers were right next to each other. I thought, oh yeah, 58 minus 42. But be careful because the 42 is actually multiplying the cos of 130. That's a package deal. The 58 is a separate entity. So we can't combine the 58 and the 42. That's just not legal algebraically. So just keep them separate and just punch it into the calculator. Okay, I get C squared. Therefore, I'm going to take the square root, and C actually equals, if I use one decimal place, maybe about 9.2. And there we go. All right, I'll put that in for C over here, 9.2. Again, we don't have to worry about two triangles or anything here. It's law of cosine, so we're safe. All right, that's the first part. Now we just need to either solve for either angle A or angle B. Either one is fine. I'm going to do angle A. Now, if I want angle A, can you figure out what side I should start with? I think because I need angle A, I'm going to start with the formula that starts with side A. So how about A squared equals B squared plus C squared minus 2 of the same BC's times the cosine of A. I need angle A, which is why I'm going to start the formula with the A squared version. Okay, now this one's a little bit trickier because we do need angle A, which means I do need the cosine of A all by itself before we think about the inverse. All right, so let's try to get this cosine A all by itself after we start plugging things in. Should we do that? So same A, B's, and C values. A was 3, so I'll do 3 squared equals. B is 7. C is about 9.2 minus 2 times 7, 9.2. Those are not squared, just B and C, times the cosine of angle A that I'm trying to solve for. Okay, just as a really quick summary of what we're going to do, we're eventually going to move these friends over by subtracting, and then eventually what we're left with is this term here So we're going to probably divide this piece on the left side. Okay, that's my game plan. Subtract the purples, divide by the orange underline so I can get cos A by itself. Shall we try it? Okay, well, let's put some numbers here. We got 3 squared. We're going to move the 49, 7 squared over. We're going to move the 9.2 squared over. I think that was, oh gosh, I can't remember. I'll use me a calculator in a sec. And then I'm left with, on the right side, remember the negative was still there, right, from over here. So don't forget our negative. 2 times 7 times 9.2 cosine of A. All right. All this stuff here, guys, all this stuff is multiplying the cos A, so I'm going to just divide it over in one big step. So I should get 9 minus 49 minus 9.2 squared, all divided by negative, don't forget the negative, this stuff. And now equal to cosine of A. And then we can do to get the A by itself is go and take the cos inverse. So therefore, over here, angle A should be equal to the cos inverse of all that mess that was over here in the green. So I can just literally take the green and cut and paste and put it right here. Take the cos inverse, and if you do it right, I'll give you a second to try it on your own. Angle A, I got about, there's a little bit of rounding because of that 9.2, but if you do it right, I got A was about 14.4 degrees. Did you get close to that? If you're off by like 1 degree or so, that's not a big deal. If you're off by like 3, 4, 5 degrees, I get a little worried of rounding, but just 1 degree is not too bad. All right, so again, I simplified this whole fraction. I plugged it into the cos inverse, and I got 14.4. And I'll put that up here on top. 14.4 degrees. Great. Now, all right, looks like I got one more angle to solve for. All right, shall we do it? Law of cosines one more time? No, we don't have to, right? Why don't we have to find law of cosines right now? Because we got 2 angles. So what if we just took those 2 angles and subtracted them from 180? Oh, that's easy. You don't have to do it twice. I would get that angle B would be about 35.6. So nice. Once you have the law of cosines to find one of the angles, you can just use basic 180-degree knowledge of triangles and get the third angle. Good. That's one example of how to use law of cosines. Given SAS, we solve for one of the sides, and we solve for the side that was opposite the given angle over here. And then we use law of cosines one more time to do the reverse, to solve for one of the angles using the inverse. And then we're good to go. Should we try one more? Let's do it. All right. Here is number 2. And I'll freshen up this page in just a second so we have room to play. All right. In number 2, I have A is 5, B is 10, and C is 12. All right, I'll give you a second to sort of set things up, and we'll join back in just a minute. Okay, friends, so I made some room here, so now we can play. First of all, let me go ahead and put these answers into my answer box. What case do we have here? Why don't we draw a triangle and find out? All right, so now it looks like if I'm given side A over here, side B down here, and side C over here, let's see, this looks like, oh, this looks like basically just side, side, side. Awesome. Okay, that's definitely law of cosines. Again, just one triangle. We're good to go. So we just need to start with any of the angles. Why don't we just go in order? I want to do angle A. Remember, if I want to solve for angle A, I should really start with the formula that starts with A squared. Ready? Here we go. How about A squared equals B squared plus C squared minus 2 times the BC's times the cosine of the angle A. All right, we have just about everything here. We just need to solve for angle A, which means, again, we're eventually going to have to use the inverse to do that, folks. All right, let's begin what we got. A is 5, B is 10, and C is 12. Everything just gets plugged in. All right. Now, again, our game plan is we're going to move the 10 squared and the 12 squared over, and we're going to eventually divide by this term right here so we get the cosine by itself, so we can inverse it. Shall we try it? Okay, let's actually use some numbers here. So we have, let me just show an extra step to make sure in case I lost anyone in the last example. And that's what we have here. Great. Now, when we subtract things over, let's bring these over and subtract. Or we can add those two terms together and subtract the bigger term. That's fine. But I basically have 25 minus 100 minus 144. And then we're going to divide by the negative 240 that was in front of the cosine of A, which will give the cos A by itself. Again, remember that negative comes over with you, so we can play. All right, we take the inverse, and A should equal the cos inverse of, well, 25 minus 100 minus 144. That's about, oh gosh, I'm using my calculator. That's what it's there for. I got negative 219 divided by negative 240. And after I take the inverse, the cos inverse, I get that angle A is about 24.1 degrees. How'd that go for you? Did you get it okay? Great job. So now I'll put 24.1 in my box. Now if you remember in the previous example, once I had two angles, I didn't have to really solve using law of cosines to get the third one. I can just use subtracting from 180. I can do that here, but I do need one more angle. So just solve for one more, either angle B or angle C, and then you can find the last one by subtracting from 180. Okay, I'm going to set up angle B, but go ahead and try either one that you like if you want either angle B or angle C. But just remember which one you use. Make sure you start with that opposite side. All right, maybe make some room here. I'm going to start with angle B. So I'll start with the one that starts with B squared. And after we plug things in, we get sometimes by mistake I actually square these terms again, which we shouldn't do. It's just A and C, but not squared, times the cosine of A. Now, I'm going to make another mistake. See if you can catch this one. I just want to do this so you can see, not that you will make it, but just to warn. I've seen this in the past sometimes. Okay, let me just simplify a little bit more before I bring things over. Okay, that's looking pretty darn good. Now watch. Ready? I'm going to say 100 equals, let's see, 169 minus 120 is about 49, right? So this makes a lot of sense, right? I can just subtract. No, why not? Remember the same reason as before? That 120 is a package deal with the cosine. He's multiplying, so they're not like terms. So I cannot bring those two together and make 49. So just be careful. It actually wouldn't work too. You get a big error in your calculator if you tried that. So be careful, guys. Don't do that step. Keep it separate. So let's go ahead and take the 169 and we'll subtract it on that side. Get negative 69 equals negative 120. And now we can go ahead and divide. All right. Room here. Cosine of A equals negative 69 over negative 120. You take the inverse. A equals the cos inverse of that, of negative over negative, which is going to be positive anyway. And I get that angle A, I'm sorry, I keep writing A's. This should be B, Mr. Brown. No one stopped me. Here we go. Let me fix all my B's for a second. That's just sloppy, Mr. Brown. Okay, apologies, folks. Welcome back. So like I was saying, angle B should be about 54.9 degrees if you got it. Again, if you're off by about a degree, that's okay. It's just rounding, but just try to get as close as you can. And now, guys, we're just about done. We don't have to do law of cosines again because we can just subtract from 180, and we know that our last angle is going to be 100 and 1, basically. And we're done. So SSS takes a little bit of work because we're going to have to use law of cosines twice to solve for the angle. So lots of inverse work. Just be careful of your algebra. SAS was not too bad. We had to solve for one of the sides first. That was pretty easy. But then we had to solve for the other angle using the inverse, so it's a little bit tricky. Okay, so like I said, the algebra is not too bad here, but thank goodness there's no SSA case that we have to worry about. Great job, folks. There's your Law of Cosines lesson for today, and you are good to go. Have a great day.